To set up our experiment, we attached a ping pong ball to each side of a metal rod. We attached the rod to a rope which dangled from another rope that was connected to a ladder. Finally, we placed 2 bowling balls equidistant to the center of the contraption.
How Cavendish did it. Cavendish set up 2 348-pound balls that were at equal distances from a wire. This wire suspended a wooden rod that held up 2 1.6-pound lead balls. He then covered the experiment with a wooden box to prevent air currents from affecting the experiment. He set up holes in this box for observation.
The smaller masses were attracted to the larger masses, causing the rod to rotate. We were able to measure L, which was the length of the rod, R, which was the distance between the center of the 2 balls, and theta, which is the angle created from the start point and the point of equilibrium.
This is how we derive G. First, we know F equals G times M1, M2 over R squared. We also know F equals K theta over L. Then we know K equals 2 pi squared M L cubed over T squared. Then we can know that 2 pi squared ml squared times theta over t equals g times m1 m2 over, we can find that g equals 2 pi squared L theta times R squared over T squared M. And that is the equation we used. Yay, that's it, the end. Goodbye.
To solve for G, we take the previously derived equation and the measurements we took, including L, R, theta, T, and M, and we put that back into the equation. As a result of this, we have gravity equals 6.91 times 10 to the negative 10th Newton meter square over kilogram square as our predicted value. Percent error is found by taking our predicted value and minusing the accepted value G, then taking the absolute value of those two, then dividing the whole thing by the accepted value of G, multiplying it by 100, to finally get our percent error of 935.5%.